Hey everyone, this is Mayu. Welcome to ML Works. In this video, we'll talk about feature selection strategies. And here are three simple feature selection strategies, that is variance threshold, univariate feature selection, and recursive feature selection. So we'll go by one and we'll understand what each of them does and how they do it. Okay, so the whole sample or this example code is available in scikit-learn official documentation. So we have taken it from there. Okay, so let's get started with feature selection strategy, which is the first one is variance threshold. So the first thing is we import the package. From there we import variance threshold, and here we have a sample of around 6 sample we have. Consider these are a set of samples and we have 3 columns. And how does variance threshold works is it looks into the change in variance of a particular feature. If there is not too much of variance in a feature, there is not much to learn from that particular feature, and it also means that all the samples have the same set of values. For instance, here are 6 samples we have, 3 columns, and if you look at sample 1, the first column is 0, sample 2 first column is 0, and sample 3 the first column is 1, again 0, 0 and 0. So there is not much variance happening in this first column, and if we compare that against second and third column, there is much more difference, or there is much more variance happening. So we can set a threshold, and based on which, if the variance is not beyond that particular threshold, then we drop this particular column. Okay, here this threshold we set is around 0.16. If we calculate zero point 0.8 into 0.02, it will be 0.16. So if a threshold is not passing that particular value, then you drop that particular column, because that doesn't add much value when you train a model on that particular feature. So what we do is we just initialize the variance threshold and pass the threshold value, and then perform fit transform on that particular set of features. Okay, so it will automatically remove that particular feature, that is the first column here, 0, 0, 1, 0, 0, 0. So that is removed, and we only have those two features which has variance more than what is the threshold was set. Okay, so that's how variance threshold works. Next we'll look at univariate feature selection. Okay, this is also similar to what the previous method. It also takes into consideration the variance of your feature, and it compares against other set of features that are available. Okay, it is like based on a threshold on F statistic score. Okay, if you look at this particular line, select K best and F classify. Select K best is nothing but it will select a bunch of features or a subset of features based on a method called F class if. Okay, which is nothing but an F statistic score of your feature. Okay, what we do is we look into the documentation aspect. Okay, first we import the packages, and train test split and iris dataset is loaded, and we know that load iris dataset is nothing but it has 4 features. Okay, petal width, height, similar to what, yeah, there are 4 features that we are aware of. Let's look into that as well. If I do this shape, okay, it does not give like that, then I have to give data. Okay, so first then data, this will give you, there are 4 features. Okay, so already we have these 4 features here, and we can let's look at the next step actually. Yeah, so first we have 4 features, and then what we do is we create a random features, okay, of around 10 features with some distribution with zero mean and standard deviation, and same number of records has this particular data set has, and we combine them together with existing features. So this particular data set has 4 features, and we add for some 10 features with some random distribution and combine them together, and then we do train and test split, and then we use the strategy of select k best. So we have 4 features which are valid features from the data set, and then we have some noisy features which we added. Now with the based on this particular approach like classify if, Okay, if we look at this particular thing, what it returns instead, it gives the F statistic score of your feature and a p-value corresponding to it associated with it. So F statistics is nothing but the ratio of variance between features. So that's what it uses to calculate the best features. So here we'll select k features, that is nothing but 4, and we'll identify the out of this, since we are adding 10 more features, there are totally 14 features, and we'll select 4 from this 14. Okay, once we run this particular cell, okay, before that we'll run this cell and add those noisy features to existing features X. Okay, and then we declare here the select k best, and then we fit it on X train and Y train, and then get the value p values, and we'll just look at this shape at the end. Okay, there are 14 features, so each features will have its own set of scores to it, which is p values, and we'll plot this score and understand which features got the more value, and that will represent its importance with respect to other features. If we see the feature univariate score, the 4 features which were added or which were there from the data set load iris, so those features have higher importance compared to the other noisy features which were added, the other 10 features. So it has selected those 4 features which were important. So this is one of the strategy to select features. Now what we do is we'll get into the next feature selection strategy, which is RFE, recursive feature selection. So what we'll do here is we'll have a data set load digits, which is nothing but our MNIST kind of a data set with 64 pixels for representing a digit, and there are around 1700 examples present. Okay, and here if we see, we initialize a particular classifier, which is SVC classifier, and then we have RFE, which is again the feature selection strategy. We pass the estimator, which is SVC, to this particular RFE, and here if we see, since I said there are like 64 pixels, so 64 pixel is the number of features that represents one particular digit. Okay, now we want to select 10 features out of that, and then we have one step. This is let's look into this particular aspect as well. One sec. Just do comma. Okay, here let's see what a step means. If greater than or equal to 1, then step corresponds to the number of features to remove at each iteration. Okay, this is a way to remove features while it is since it runs iteration by iteration SVC. So how many features to remove? So that is the strategy here with the step we are giving in. And what we'll do is next we fit this particular RFE on X and Y, and then we'll rank those features. We'll get the rank of those features from the RFE, which we'll see here. We'll get it here, and then we'll plot those. Now since we are getting rank for each of those pixel values, we can plot that particular rank like a grid. Okay, like as it is shown here, matrix. So let's run this. So if we see what it means, that rank means if a feature has a low rank of 1, it means that is the most important feature. Okay, so if we look at in this pixel ranking, okay, the features like these, which are white in color, these are important features. Okay, so these are important features because they have high rank, which is in a means like rank of less than 10, you can see, because it has rank 1, 2, 3, 4, 5, something like that. Okay, these are important features. So why it is giving that rank to these features? Because if you look at this particular image, which is nothing but images of 0, okay, let me just first look at what the data set. It has around 1800 records, 64 pixels. And if you look at the first image, for which we are getting the ranking of pixels based on feature selection. Okay, if you look at this particular image, it is nothing but the value of 0. It's a digit 0, and these are the feature importance. Now if we look at this strategy, it has ranked those pixels which represents zeros as high, because these are having the least rank. It has high value, these features. So this is one of the strategy to select the best features. Okay, here we are selecting features to select as 10. Okay, we give it as 1. Okay, so yeah, it's still running. Okay, and if you want to select around 40 features, then we'll see that majority of those pixels which represent 0, that are turned into what, value of 1, rank 1. Okay, so we'll keep it as 1 and we'll select those features alone. It will select only one feature for that in that case. Yeah. So these are some simple strategies to select features, which will help us in what, reducing the data set size, and it will also help us in generalizing the machine learning model on your data. So that is why we go for feature selection. So with this, I'll conclude this particular video and see you in the next. Thank you.